So far, we've seen that GeneXus defines relations between transactions and between tables based on the names of attributes that it considers equal to one another. For instance, the country ID attribute is in the attraction transaction where it has a foreign key role because it is present under the same name in the country transaction, where it is primary key. In turn, the country name attribute is also in both transactions under the same name. So, GeneXus understands that it's the same attribute. In this case, it is not a primary attribute, and therefore GeneXus will decide to store it in the country table instead of in the attraction table. We can then say that GeneXus always assumes that, if we use the same attribute name, then we're representing the same concept. However, there are cases where we might need to use different names for a single concept and indicate to GeneXus that the two names have the same meaning. Let's see how this works. Let's suppose that the travel agency needs to record the flights offered to customers for arriving at a particular tourist attraction. We must record for each flight the departure airport as well as the arrival airport. To represent this, first we will create a transaction under the name flight. We define the flight ID attribute, which is automatically based on the ID domain. Now let's think of what other information we should record. As we said, each flight will have a departure airport and an arrival airport. But we will have to record each airport on its own in order to later reference them from the flights. So let's leave the flight transaction aside for a moment and create another transaction called airport. We then define that each airport has one identifier that is airport ID. A name, airport name, and is located in one country and in one city. So we will add the attributes country ID, country name, city ID, and city name. We save. And now we go back to see what our requirement was in the flight transaction. To each flight, we must add its departure airport and its arrival airport. So we go back to the flight transaction and add the airport ID and airport name attributes. But when we try to add airport ID again, GeneXus tells us there's an error. That is, we're trying to add an attribute with a duplicate name. And the same will happen with the airport name attribute that we were going to add to represent the name of the arrival airport. So, what can we do to enter two airports in one transaction? Obviously, we will have to use names of different attributes to store the flight's origin and destination information that we want to record. Let's then delete the attributes we originally entered and define attributes with new names. We will call the flight's departure airport identifier with the name Flight Departure Airport ID. And the name of the departure airport will be Flight Departure Airport Name. So, now we have defined new attribute names, but to GeneXus, these attribute names are not related to airport ID or airport name. As we said before, If we use different names in the flight and airport transactions to identify the airport concept, then GeneXus will not define any relation between the two transactions. To verify this, we will create a transaction diagram. And we will drag the airport and flight transactions and we see that, in fact, GeneXus does not find any relation between them because no foreign key was identified in flight to allow the relation with airport. Another way to consider this is to focus on the way in which GeneXus shows the airport identifier attribute within the flight transaction. We can see that it's indicated with the square symbol, meaning that it is a secondary attribute and is not considered a foreign key. Let's compare this to the country identifier definition in the attraction transaction. In attraction, the country ID has an arrow pointing upwards, indicating that it is a foreign key attribute. But that is not the case of the flight departure airport ID attribute in the flight transaction. So, how can we get GeneXus to relate different names to a single concept? We need flight departure airport ID, even with a name different from airport ID, to be considered as such. That is, as an airport identifier. And the same goes for the airport name. But how can we make this happen? The answer is by defining subtypes. When an attribute has a name different from another attribute already defined, and they both represent the same concept, we can inform GeneXus that the new attribute is a subtype of the other attribute. From that moment on, to GeneXus, they will be exactly the same thing. So, GeneXus will consider the attribute flight departure airport ID just as if it was an airport ID. That is, it will identify it as foreign key in the flight transaction. And we'll do the same with flight departure airport name. We will indicate that it's a subtype of airport name. Now, let's see this in action. The first thing we must do to define subtypes is create a group of subtypes. So, we create a new object of the type subtype group and name it flight departure airport. In the first line here, we type the dot, and GeneXus suggests the attributes that start by flight departure airport, which we'd already defined in the flight transaction. We then select flight departure airport ID, press tab, and for flight departure airport ID to be a subtype of airport ID, we select the attribute airport ID as supertype. Now we add flight departure airport name and define that its supertype is airport name. Then we save. Now let's go to the flight transaction, where we will see that the flight departure airport ID attribute has the symbol of the arrow pointing upwards, indicating that it will be considered as foreign key, and also the letter S symbol, meaning that it is an attribute defined as subtype. Now let's do the same to define the attributes that will enable us to record the flight's arrival airport. To do that, we will define attributes flight arrival airport ID and flight arrival airport name. Then we save. We now create a new object of the type subtype group with the name Flight Arrival Airport. We type the dot, and GeneXus suggests the attributes starting by Flight Arrival Airport, so we select Flight Arrival Airport ID. We press Tab and declare that it will be a subtype of Airport ID. Now we add Flight Arrival Airport name and define that its supertype is airport name. Then we save. Let's take a look at the structure of the flight transaction again. And let's analyze a diagram now, either of transactions or of tables. We drag transactions airport and flight and the relations now show that GeneXus considers the attributes as subtypes that are airport identifiers in flight, just as if we had referenced airport ID. We can see that GeneXus has found the relation between flight and airport. Let's see how all this functions. To do so, we press F5. We'll start by defining airports, so we'll execute the airport transaction. We enter the Guarulhos airport and indicate the corresponding country, Brazil, and city, Sao Paulo. Now we will enter the Charles de Gaulle airport. So we select France and the city, Paris. Now we confirm. Now we will go on to record a flight. We now execute the flight transaction, and as departure airport, we will select Guarulhos, while our arrival airport will be Charles de Gaulle. Now we will enter another flight. If we try to type in Airport 15, we get a message indicating that the airport does not exist. Now, if we use this little arrow, we can see that we have the same controls and help as if the attributes were the foreign keys with their original names. But in this case, they are their subtype attributes. And that was exactly the idea, to define subtypes in order to determine that different attribute names correspond to the same concept. So, we've seen that using subtypes enabled us to represent a situation that occurs in reality, such as in this case, the flight with two airports with different roles, one for departing and the other for arriving. Something we should note here is that although we defined attributes with descriptive names that respectively refer to the departing and arrival roles, it was also highly important to group, in the same group of subtypes, the attributes that correspond to one another. Note that we have not included all the subtypes in a single group, or the two primary subtype attributes in one group, and the two secondary attributes in another group. We've grouped together the attributes that define the departure airport, and in another group, we included the attributes that define the arrival airport. And this is so because GeneXus understands with this group that when a value is entered for airport identifier flight departure airport ID, then the name of the airport corresponding to this identifier must be loaded in this flight departure airport name attribute, and not in the other airport name we have in the transaction. Likewise, GeneXus understands that when a value is typed for the airport identifier, flight arrival airport ID, the name of the corresponding airport must be loaded in the flight arrival airport name attribute. Now let's suppose that in the flight transaction, for each airport, we want to see, besides its name, its country and its city as well. This may be solved by simply defining more subtype attributes in each group necessary, with the adequate naming and with indication of their supertypes. This will allow GeneXus to understand that, for the group's primary subtype, it will have to infer all the remaining related information. Let's do it. In this group of subtypes, we will define the following attributes: flight departure country ID as subtype of country ID, flight departure country name as subtype of country name, flight departure city ID as subtype of city ID, and flight departure city name as subtype of city name. We now save, and we will also add these new attributes to the structure of the flight transaction. We save again, and we go on to do the same for the other group of subtypes. And we define flight arrival country ID as subtype of country ID, flight arrival country name as subtype of country name, flight arrival city ID as subtype of city ID, and flight arrival city name as subtype of city name. We save. And after saving, we also add these to the structure of the flight transaction. We save, and then press F5 again to execute the application. Now we open the flight transaction, and when we check on our first flight, we can see for each airport its corresponding country and city. We have seen how to solve a double reference to the same concept with different roles, because the two airports must be obtained from the same table, where each of them had a different role. To end, it is important to know that also these could have been equally valid solutions. In the first proposal, a single group of subtypes has been defined, the one corresponding to the departure airport, and the supertype attributes were left for the entry of the destination. And this is totally valid. In this other proposal, a single group of subtypes has also been defined, but in this case for the group corresponding to the arrival airport. In sum, subtypes enable us to indicate to GeneXus how to associate different attribute names to a single concept. And as we saw, validations as well as all the behavior of subtypes will be identical as if we had used the supertype attributes. To end, we'll update the changes on GX Server. We'll add a comment and press Commit.